Web for Pentester II, SQL Injections. In this section, some common SQL injection examples are provided. The first examples are authentication bypasses, where the other ones are more traditional SQL injections. Example 1. The first example is the most common SQL injection example that you can find. The goal here is to bypass the authentication page. This example is the best known way to bypass an authentication page. It's even used in a lot of comments related to SQL injections. Let's see what happens. The initial query looks like: select everything from users where username and password. Our payload will be a simple code or 1 equals 1, which is a true statement that we have used before, and this payload can be optimized to simple code or 1 and encoding, which is the hashtag. Let's try this in the server. Example 1, single quote or 1 equals 1. We can add the hashtag for the encoding, and the password can be anything. Let's try it. As you can see, success. Let's move on to example number 2. Example number 2, this example is the same vulnerability with a twist. In the first example, the code only checked that something was returned. In this version, the developer decided to ensure that only one user exists. To bypass this restriction, you can get all the rows with the trick seen above, and then limit this number using the SQL keywords limit. So, same as before, simple quote or 1 equals 1, limit this time, and the encoding at the end. The password again can be anything. Let's send the query, and as you can see, success. Example 3. In this example, aware of the risk of SQL injection, the developer decided to block single quotes by removing any single quote in the query. However, there is still a way to break out the SQL syntax and inject arbitrary SQL. The problem here is that you cannot, in theory, break out of single quotes, since you cannot inject any quote. However, if you inject a backslash, the second single quote in the query, the one that is supposed to finish the string, will be escaped and will be closed by the third one. Let's move on to the server, and let's add a backslash to escape the second single quote, which would close the query. Let's either add here our payload, which is or 1 equals 1 and the coding, and let's send it. So you can see success. Let's move on to example 4. In this example, the developer puts part of the query directly in the parameter. It's really rare in the traditional web applications, but can sometimes be found in web services, especially for mobile applications. You are injecting directly in the where statement and can manipulate the rest to retrieve anything you want. So example 4, as you can see here, he is using the query to retrieve the username where it equals hacker, and let's add our payload at the end, or 1 equals 1 and encoding, and as you can see, we got the rest of the users of the table. Let's move on to example 5. Example 5 says, in this example, you are injecting after the keyword limit. On MySQL, this type of injection can only be exploited using union select. If there is no order by keywords used in the query, furthermore, the order by keywords needed to be located before the limit keyword. So let's move on to the server. Example 5. Let's add our union all, and our, let's say, second query, select everything from users. As you can see, it union both queries to both tables, and we got all the results. Example 6. This is another example of SQL injection, but this time, after the group by keywords, union-based exploitation can also be used to exploit this type of feature. The good thing is that order by will be located after group by, so even if order by is used, you can get rid of it using SQL comments. Let's move on to the server, sample 6. In this case, I will just delete the group keyword and go ahead with the rest of the query. So delete this, and as you can see, we got all the registries from the table. Now, example 7. In this example, 2 queries are performed. The first query retrieves the user details based on the parameter ID, and the second one uses the username from the previously retrieved record to retrieve the user. So, to exploit this issue, you will need to use blind SQL injections. However, since the error messages are displayed, we can use error-based exploitation to get the information. Okay, in this case, we will use a tool called SQL Map to help us do the SQL injection, the blind SQL injections to the database. I will go and head for sample 7. This will be our ID that we will be attacking, and let's try it here. SQL map Python SQL map.py -u for the URL, and as you can see, HTTP vulnerable SQL injection example 7. Let's go ahead and hit start. You can see there the tool is running. And here it says some error, some exploits we could use, but let's add to that query dash dump, and it will get for us all the registries in the table. Let's hit enter. It says, do you want to store hashes? No, I do not want to store hashes. Neither want to crack them via a dictionary based attack. And as you can see, here we got the table, users, the ID of all the users, the usernames, and the respective passwords. Let's move on to example 8. Sample 8 says, in this example, is vulnerable to second order SQL injection. Instead of directly injecting your payload into the request, you will first insert it in the database using a first request and then trigger the payload in a second request. The first request is not vulnerable to SQL injection, only the second is. However, you do not directly control the value used. You need to inject it using the first request. Basically, let's move to a server. Sample 8. we will add here our payload, or 1 equals 1, and the coding, and the password can be anything. We'll hit create user, and we are not directly injecting the payload, but rather when we hit here, the payload is being injected. And let's try it with this time injecting the payload in, injecting the payload in the password. For example, hacker, single quote, space, or space 1 equals 1, and the coding would create user, and we reheat it. In that moment, the payload is being run. Example 9. Example 9 says, in this example was first published in 2006 on Chris Shiflett's blog. As a way to bypass my SQL real escape string, it relies on my SQL will perform escaping. It will depend on the char set used by the connection. If the database driver is not aware of the char set, it will not perform the right escaping and create an exploitable situation. This exploit relies on the use of the JBK. JBK is a character set for simplified Chinese, using the fact the database driver and the database don't talk the same char set. It is possible to generate a single code and break out of the SQL syntax to inject the payload. So we will use that JKB and char set with the following payload. Let's move on to the server. Paste it here. So paste it here. The password again can be anything, as you can see, the JBK character, and send the query. Success.